Let's work on some example problems that are similar to problems that you'll see in your homework. The first one here we have let d of x equal to the quantity x minus 6 squared. That's going to be the price in dollars per unit that consumers will pay for x units of an item. We're going to let s of x equal x squared be the price in dollars per unit that producers will accept for x units. Find the equilibrium point, the consumer surplus at the equilibrium point, and also the producer surplus at the equilibrium point. So we're given the demand and supply functions, and we're going to begin by finding the equilibrium point. Now to find the equilibrium point, what we do is we set the supply and demand functions equal to one another and solve for x. Keep in mind that the equilibrium point is the point at which the supply and the demand curves intersect each other. And in context of a problem, it is the ideal point at which buyers and sellers kind of come together and purchases and sales actually occur. So if we set the demand function equal to the supply function, then we're looking at x minus 6 quantity squared equal to x squared. And we want to solve for x. So we're solving a quadratic here. Let's first multiply out the left-hand side. So we have x minus 6 times an x minus 6 equal to x squared. Multiplying out the left side, we have an x squared minus 12x plus 36 equal to x squared. Here we can actually subtract an x squared from both sides. So we're left with a negative 12x plus 36 equal to 0. Now solving for x, subtract 36 from both sides. So we have a negative 12x equal to a negative 36. And then let's divide both sides by a negative 12. So we're left with x equal to 3. That is our x value for our equilibrium point. So that would be the number of units of an item. To find the corresponding price, we plug our x value into either the demand or the supply function. Doesn't matter which one, we'll get the same answer either way. So if I plug 3 into our supply function, we have 3 squared, which is 9. So $9 is the price for the equilibrium point. So we could write the point as 3, $9. And that is our equilibrium point. Next, we want to find the consumer surplus. Now to calculate consumer surplus, let's think of our equilibrium point as x sub e comma p sub e. That's the notation we can use here. So to calculate consumer surplus, we're going to integrate the demand function. We're going to integrate from 0 to x sub e, where x sub e is our x value of our equilibrium point. And then we're going to subtract from that the product of x sub e times p sub e, where p sub e is our price of our equilibrium point. Now the demand function is a decreasing function, and so we can think of consumer surplus as the extra utility that consumers enjoy as the price decreases. Alright, so let's calculate the consumer surplus. We're integrating from 0 to 3. Our demand function looks like x minus 6 quantity squared, and then subtracting off our x value times our p value for the equilibrium point. So 3 times 9. Before we integrate, let's multiply out our demand function. So we have 0 to 3, and then we have x squared minus 12x plus 36 dx minus, and then 3 times 9 gives us 27. So now let's integrate here, and we have x cubed over 3 minus 12x squared over 2 plus 36x, and we're integrating from 0 to 3, and then we have this minus 27. Notice that the negative 12 over 2 here will reduce, so we can make this a 6. So now let's plug 3 in, and we have 3 cubed over 3 minus 6 times 3 squared plus 36 times 3. That's what we get when we plug 3 in. Now subtract from that what we get when we plug 0 in. If we plug 0 in, though, we just get 0 minus 0 plus 0. So that's 0. and then we have the minus 27. So simplifying here, 3 cubed is 27. 27 over 3 gives us a 9. Minus, we have 6 times 3 squared. 3 squared is 9 times 6 gives us a 54. Plus 36 times 3, which is 108. And then we have minus 27. This simplifies to give us 36. So $36 is our consumer surplus at the equilibrium point, $3,9. Now if you would like a visualization of what we just calculated here, let's take a look at the graph of our demand function. If we graph our demand function, it is a decreasing function that looks something like this. And then what we calculated here, this first part is the integral of our demand function from 0 to 3. So here at 3, this point, our equilibrium point, is 3, 9. 3, 9. So in calculating that integral, what we first calculated here, the area under the curve, was the integral gives us all this area under the curve from 0 to 3. Right. So that is this first part here, the integral. And then what we subtracted from that was 27, 3 times 9. Well, that can be represented by looking at a rectangle here. A rectangle with width of 3 and height of 9. Now, it's not really to scale here, but you can get an idea. And we're subtracting off that. So subtracting off that rectangle leaves us with everything up top here. So this everything in yellow here is what we're left with. And that right there represents our consumer surplus. Now the last part of our problem asks us to find the producer surplus at the equilibrium point. So to find the producer surplus, what we do is we use our equilibrium point and we multiply the x and the p-value in our equilibrium point. So we take the product x sub e times p sub e, and we subtract from that the integral of our supply function, and we integrate from 0 to x sub e, where x sub e is our x value of our equilibrium point. So here what that's going to look like then is 3 times 9 minus the integral of 0 to 3, our supply function is x squared in this case, dx. So we have 27 minus, now we need to integrate x squared. So we have x cubed over 3, integrating from 0 to 3. So plugging 3 in, we have 27 minus, if we plug 3 in, we have 3 cubed over 3, and then minus what we get when we plug 0 in. If we plug 0 in, we just have 0. So this is going to look like 27 minus 3 cubed is 27. 27 over 3 is 9. Alright, 27 minus 9 gives us 18. So the producer surplus then is $18. If we want to get a visualization of what we just calculated here, let's look at a graph of the supply function. And in this case, our supply function is x squared. So if I graph x squared on the interval 0 to 3, it looks something like this. So out here at 3 is our equilibrium point, and our equilibrium point was the point 3, 9. So there is 3, 9. And then in calculating the producer surplus, we first calculated x sub e times p sub e. So that is a rectangle. We multiplied 3 times 9. So that rectangle had a width of 3 and a height of 9. I'm not really drawing the scale here, but you get an idea of what we calculated. And so that is the area of this rectangle, 3 times 9, which was 27. And then what we did is we subtracted from that the integral of the supply function from 0 to 3. So that is the area under the supply curve. So we subtracted off all this area under the supply curve. So all this area here is what we integrated, and we subtracted all of that off. So then what we are left with then is everything above the supply curve. So we're left with all of this. Alright, so that gives us our producer surplus, everything there in yellow.